In today's lecture, we will discuss the Python for beginners again. Our topic today is the logical operators. These are the operators that connect two conditions on some logical decision. And we will build the compound Boolean statements. A Boolean statement is a statement that has an answer of true or false. And then we will also have some example programs to demonstrate that. So before I go further into logical operators, first I have to tell you what logical operators do we have on our hand. So the very first Boolean operator that we are going to use is called the AND operator. So the AND operator requires that the conditions on its either side are true. So let's say I have a condition simple x and I want to check if, and this is my condition, that if x is greater than y, right, and x is also greater than a variable z, then I want to print that x is largest, right? Then I want to print the value of x, and then I want to print is largest, right? Is the largest. So here what I did was I made my decision on the value of x and y, this condition, and also on this condition. So let's say I have a value x is equal to 4 and y is equal to 2, and let's say z is equal to 1. In this condition, x is greater than y. You will say yes, this little Boolean expression in itself is true. Then we say is x greater than z, x is 4, z is 1, so that is also true. Now the conditions on either side of this operator are true, so the overall result that this if statement is going to see is also true, right? Now in the case that we change the value of y to 12, let's say I change the value of y to 12, then what will happen is this condition x greater than y is not anymore true, it is false, right? Although this is true, but since both of these should be true, our overall result is going to be false. So what we can say about the AND statements is true like that. So you can have a condition, if I call it C1, it could be x greater than y or something. I'm just using a placeholder value. And I have a condition that I'm trying to get and C2. So I want to check C1 and C2 and I want the overall result. Now if C1 is true and C2 is false, the answer would be, the overall result would be false. Always remember that, right? Now if C1 is true and C2 is true, then both of them are true, our overall result is true. If C2 is false, C1 is false and C2 is false, our result is going to be false. If C2 is false, C1 is false and C2 is true, our overall result is going to be false. So the only time our result is going to be true is when both conditions are true, right? So this is called an AND operator. So for example, I want to buy a book that is written on a certain topic, and it also must be available in the library or kind of on my bookstore. So I will check both conditions before I go to buy the book. And then we will also do some examples, then how do we write that in our program. Now the other condition that I have is the OR operator, which is written as, so in that in the OR operator, either condition can be true to make this true. Either first one is true or the second one is true. So let's say I have a condition where I want to check if x is greater than y. Just to take the same example, and then I will use the OR operator, and then I want to say or x is greater than z. So I would be just happy if x is greater than one of those. And I do the print statement. I'm not going to write the whole thing, but you know, I write my print statement that x is, I have x is greater than y or z or whatever decision I want to make. In this case, I have, let's say x is equal to 4 and y is equal to 12 and z is equal to 2. So when I come in here, this condition is definitely false, right? But this condition is true. So OR requires me only requires that only one of them should be true. So though my overall answer would be true. So if we make a table like this type table is called a truth table. If we write our truth table for them, I will have, if I keep one condition on one side of OR and another condition on other side of OR, and I say if this is true and this is false, our overall answer is going to be true. If this is true and this is true, our overall answer is going to be true. If this is false and this is false, our overall answer is going to be false. If this is false and this is true, this one is false, so don't confuse it with a T, sorry. And if this is false and this is true, then our overall answer is going to be true. So what do we see is that the only time it can be false is when both of them are false. So you can think about that. If I look at the AND operator and if I look at the OR operator, they are kind of similar but also different. Of course, they check the different thing. It is true only when all conditions are true, right? When all conditions are true, that's only time when it is true, right? Can you say a similar sentence about the OR statement? So the only thing I would have to say is that it could only be false when all conditions are false, right? So I can just copy the when all conditions are false. So when all conditions are false, so it would be true otherwise if either one of them is true. It's very important, sometimes we use these, right? So these are two operators that we will use a lot, but there is another one. There is one that is called a unary operator, which is a NOT operator. We call it a NOT operator. What does that mean? That means that if that condition is not true. So how would we do that? We use that in the equal sign, right? So the word not is kind of replace the exclamation mark when we use in the equal to sign. When we use the not operator, that means inside that reverse of what we have just calculated inside or by a calculator. So if I have, let's say I have x is equal to 4, y is equal to 5, and I have a condition, let's say I want to say if x is less than 5, right? I'm pretty happy. But x less than 5 or x less than y, I will say. So this condition is true, but if I put a not in front of it, then this condition is false, sorry, but not reverses it, so it becomes true. So overall result, the if statement we'll see is the true statement. So let me give you another example. I have x is equal to 4, y is equal to 7, and let's say z is equal to 5, right? I have this, right? Then I wrote down my if statement and I said if, and I'm going to put not x greater than y and x less than z. So how do we evaluate the overall result? That would be, is x greater than y? That is false, right? But going through the not, that has become a true, right? Because not just reverses the operation. And then when we come in here, x is less than z, this is a true statement. So the overall result will be calculated from these both ends, and our answer would be a true, right? So let's see how do we write that in Python. So I have some word problems that we read through and write the program using our logical operators. So read through this problem statement. We want to write a program that help us decide whether we should buy a washer or not. Our requirement is that must have at least an average of 4 stars in review and must not cost greater than $1,200. So these two conditions must be true. And you can see the word and in here. So we have to check the review ratings and we have to check the price. So we should ask that in our program and then make a decision using that. So let's pull up our IDLE and then write this little program. And I'm going to write my new file in here, and again I want to write some comments. You guys might want to write that. So according to our statement, so we have to ask the reviews, average review, right? And we have to ask the price so that we can use that to make our decision. Okay, so let's go in here and first let's ask the review. Now review, okay, just say R rating, because you know we want to get review rating. And now could it be a float or an integer? It could be a float because you can have 3.5, right? So we can say float type data is about to come in. Where does it come in? It should come in from the input. So we have no problem. We have done our previous exercises. Like I said, it will be beneficial if you take it in the order I have listed them. And in here I will say please enter the average review. Right, so we kind of getting the average review rating from the user. Okay, now the next thing is that we have to get the cost. We also want to make sure that we have the cost, and that for cost always can be float, right? It could be, money can always have the fractional part. So we come in and we say input. I want to say oh I accidentally turned the wrong one, and here I will say please enter the so now we have to make a decision. So we come in, our issue was that the R rating or the review rating must be at least 4. So at least 4 means must be greater than or equal to 4, right? And then we are going to combine our next condition, and our next condition is the cost must be less than 1,200, right? And we make our decision in here. Now, because what I really like to do is I want to put my condition, although not necessary, but for a visual separation, I want to put them in separate, parentheses, so I can visually see them differently. So I want both of these conditions to be true. If they are true, then I'm going to print, wow, buy this machine. Right, this is machine that we want, or buy this washer. Okay, else if this is false, then we what to do is print we are not buying this machine. We don't want this machine. So again, we have to have both of these conditions to be true for this statement to print. If one of them is false, then or both of them is false, then we are not going to buy this machine. Okay, so let's save this file and run it. Now let's go to run, and it will automatically ask to save the file, and I say run module, and it says we have to save it. Okay, to save, so let's save. I have made this in here, so here I will save, let's say I will call it washer. Well, you can name it whatever you want to. Make sure their Python files are selected in here, otherwise it will just be a random file. Okay, we got that, and it's asking the average review rating. We should have put some space in there, so let's say the average review rating is 4.2 or 4.3, and the washer costs 1400, sorry. We are not buying this machine because what failed was this condition, right? So let's go back again and run it again, but kind of make a little bit of a space here so it doesn't look ugly as it looked before. So let's run this again. It's asking the average review rating. Okay, did I not save it? Hold on. Oh, yeah. hold on, I put in the wrong place. That was okay, we don't need to put that, we have to put this in here because it looks really ugly. So again, sometime we make the program for the user, right? We don't make it for ourselves. So make sure it looks good looking. It is a good looking program for the user, so it doesn't look bad now here. So let's say our rating is 4.1, and then when you come in here, the price is $1,150, and let's say 75 cents as well. Oh, I put a comma, so this does not get recognized, so I made a mistake while entering my data. I should have entered the point, not the comma. Let's say my rating was 4.1, and then it was $11.50 and 50 cent and $50, $1,150.56, and we are saying buy this machine. So that way we can have the if and else. Now another example that I want to show you is a little game that we can play, the rock paper scissors, that we can play with our computer. So first let's take a look at the description. So read through the description. We want to play rock paper scissors with the computer. We use 1 to represent rock, 2 to represent paper, and 3 to represent scissors. So if the user enter 1, that means they are choosing the rock. If the user enter 2, they are choosing the paper. If the user enter 3, they are representing the scissors. Computer at the same time, what we'll do is it will choose a random number between 1, 2, and 3, and we will enter our number. That should be our number, not out number. We will enter our number, and then we will decide who has won the game by using this rule. So if the user has chosen paper and the computer has chosen rock, then user has won, right? Because paper covers rock. And all the conditions are in here, right? But these will be numbers for us, like 1 paper would be 3 beats 2, right? I think, yeah, no, sorry, 2 beats 3, and so on, right? So we will keep that in mind, and we will write it as a comment in our, so this is going to be our first little program, serious program that we are going to write, a game. Okay, so let's start writing our rock paper scissors game. So I will bring it in here, and I will open a new file, and I will just make some notes in here. It's easier sometime. I will of course always write my name in case we have, and I also would write a name of rock paper, or paper scissors rock. I forgot what is the name. Okay, and we will also write we come back and we decide what we have decided. 1 will represent rock, so 1 is equal to rock, and then 2 represent the paper. Actually it's rock paper scissors, so I wrote the name differently, but you know, and then 3 represent the scissors, right? Now what we have to do now, we have to make sure our computer can do the random number. For that we have to use help of random library that we can use from computer. This is not by default a part of the library of Python, but we can get it. So we will say import, that means please give me the random library that I can use. Then what we will do is we will choose, we will write import random, that will help us use the random numbers, and then we will see is that ch is equal to a random number. Let's see, call it computer choice, right? So computer choice will be a random number generated from this library. For that purpose we will say random dot range, I'm saying random range 1, 4. What would it that be is I want to get a number between 1, 2, and 3. Now 4 is here because it will not go up to 4. It will stop before 4. So it can choose any number starting from 1 but less than 4. So it is 1, 2, 3, or 4, right? So our computer can choose. Now for the sake of seeing whether it is doing the good job or we are getting the number, just print it out, the ch, but when we start actually playing the game, we will take it out. Right now we are just doing the debug and we are trying to see whether it is working as it should be working, right? So let me start, let me run this at this stage, although our game is not complete, right? Our game requires completion. So I will just come in here and I will save it as the game, right? And okay, so I do the game, I save it as a game, and let's say so the computer has chosen 3. Very good. Let's see if I do it again. Is the computer choosing between 1 and 3? Computer has chosen 1. So we are doing great. Our computer choice is working right. Now what we have to do is we have to choose the user. We'll ask the user. So we will say user choice. And in that case, I will say that will be an integer, right? And then where it is coming from, it's coming from an input. Now we have to guide the user, otherwise they will be confused, right? So we will say please choose. Now if we do that, then and we can do is 1 for rock, right? They can choose 2 for 2 for paper. Now they can choose, right? And 3 for scissors, right? And right now we are not doing anything that we are not kind of go through that the user might choose a, you know, kind of like something like 4 or 5 or something. Right now we are not doing input validation. We think that the user is smart enough and they will be able to choose correctly. Now the first thing come up, what if they both have chosen the same thing, right? So first we will make sure that the computer choice, right, and sorry, computer choice, if the computer choice is equal to user choice, right, in that case what has happened is that they both have chosen the same thing. The game is a tie. But now come back the criteria, what else, if, sorry, we will use the elif what do we want to check? So we have the if, and elif is the part of that. If computer choice is equal to 1, right? And so 1 and we will try to see all the combinations that computer can win, and of course if the computer didn't win, the user wins. So we will go through all the choices. If it is 1, then the user choice should be so if the computer has chosen rock and the user has chosen scissors, then of course rock beats scissors. Now this is one way computer can win, right? I'm going to put that in parentheses so I can understand. Okay, I have to remove this. I'm sorry, I use this C and Java style thing. I have to use the AND. Now what are the other conditions? Or there are other conditions that can happen. So I'm going to copy this. What are the other combinations that can make the computer a winner? If computer has chosen 2, what should if the computer has chosen 2, that means the user must have chosen the rock because paper covers rock. This is one other condition that can make the user win, right? Or computer has chosen, we have chosen 1, 2, and 3. What if the computer has chosen 3, which is the scissor? Then how can the computer win, right? Then the user must have chosen the paper, right? Let me go back in here so you can see. If we have chosen the scissors, the computer has chosen the scissor, then the user must have chosen the paper because that way they can win, you know, because scissors cut paper. Let me kind of put it on a second line so you can see, and the user has chosen 2. So these are the possible values that computer has chosen and the user has chosen that will make the computer a winner. Now if there are other combinations, first of all there could be a combination they both have chosen the same thing, so we got that out, so they are not choosing the same thing. Now what are the different combinations that can make computer the winner. So we have put all of them in here, that if it has chosen the rock and the user has chosen the scissor, that will make the computer a winner. Or if computer has chosen the paper, then the only way it can become a winner is if user has chosen the rock, right? And then because paper covers rock, and so on, right? So I'm going to put them back in one line, although it is hard to see, but let's see if Python let me do that. If I can make it a little bit a longer line, sometime it fusses, but I think for visual. So what I have done is I have all the possible combinations that can make the computer a winner. So if they are not the same and that's not one of them, then I will go at the end of this sentence. And I'm going to put this in here. In that case, what happens? We will print, because that are all the possibilities that makes the computer a winner. Right? Now, if they are not choosing the same thing and computer has not won, then what is true? In that case, I'm going to cat this, all of it on one line. So that looks good. In that case, the only possibility left is else. So they're not the same. Computer hasn't won. That means the user has won, right? Because we have no other combination. So you can see an example of multiple. So I have these multiple conditions connected together. If both of them is true, then this whole thing is true. If one of them is true, because of the OR statement, we get this game. So this is how we write the paper scissors game. Let's play. It will ask me to save it. Okay. And it's asking me to well, we have a cheat here, so we can see that computer has chosen 1. So that is rock. So we will say 2 because paper covers. Oh, I'm sorry, I put the printf in there. That should be a print. We don't use printf in here. Sorry. Control S, my problem. Let me save it and run it again. Made a mistake in there, but come in here and we have, according to our cheat, we can see that computer has chosen 1, and then let's choose 2 and we can see we won, right? Now let's play again and let's see if the computer has chosen something else. Computer has chosen 2 in this time. So paper. To win it, what do we have to do is paper covers rock, right? So computer has chosen, no, we have to choose 3 because scissors cut paper, otherwise you lose, right? Now let me go back again and then run it again, and we say that computer has chosen 3, and let's say we also choose 3, and then the game is a tie. So to be fair, take this statement out. We don't want to see it anymore, so play fair, right? If we play fair, we go in here and we say we don't know what the computer has chosen. We have no clue what the computer has chosen, but we randomly chose 3. Well, we won. So this is how we write a simple game using the Boolean operators and the compound statements. If you like this video, please subscribe to Professor A's CS Academy.